Hi kids, this is your lesson 1, star charts from unit 3. Constellations are star groups that seem to travel together in a group. Star charts exist to help follow the changing pictures of the heavenly bodies. It's like a guide. And each season, meaning summer, spring, winter, fall, each season has its own pattern of stars. They follow a set pattern. Once you recognize some of the principal constellations, you can use them as a guide to find the other ones. Okay, so we're going to review really quick your vocabulary for this lesson, and then I am going to explain. Okay, one of the words that you gotta learn today is constellation. Constellation, it's a group of stars that has a pattern or a shape. For example, you could hear about the constellation of Orion or of the Swan. And then it's just like they have a name, so it's easy to identify them. Then you have the word cosmology. Cosmology, it's the science or the theory of the origin of the universe and how it works. Then we have the word meteor. Meteor, it's a mass of rock or metal that enters the Earth's atmosphere. And then meteoric has to do with meteors. And then you got a difference between meteoroid, and then meteorite. Sounds really similar, but it's different because meteorite, it's a mass of rock or metal that has impacted on the Earth's surface, meaning it's on the Earth. Meteor, it's that it's entering the atmosphere, but meteoroid, it's one that is traveling through space. Then we have the North Star. It's a bright star directly above the North Pole. Retrograde means something that it's moving backwards. Another word is the Summer Triangle, which is Vega, Deneb, and Altair. It's a group of bright stars in the summer that you can see, a constellation. And then Zenith. Zenith, it's the point in heavens directly overhead, meaning up your head. For the winter sky, and I'm going to talk really quickly about what Ignitia says, and don't freak out, don't get scared if you don't understand all of the different constellations. It's just to give you an idea, okay, about like the names, what do they mean. You don't have to know the place where all of them are unless you love astrology, which is cool. Well, I'm sorry, astronomy. That's an important difference that Ignitia is going to ask you a lot. Astrology means it's a superstition, like people thinking that the stars play a role in their daily life, like the horoscope, which we don't believe in. And then we have astronomy, which is the science of the stars and the universe. That we believe and we love. Okay, so for the winter sky. Okay, the winter sky. February, it's the best month for stargazing, but that's in the northern hemisphere, not the southern hemisphere where we are. You can see there Orion the Hunter, and you can see what else? Tiger, which is a blue star. You can see Sirius, which is the second brightest star in the sky. You can see what else? Aldebaran, you can see the Pleiades, you can see Canis Minor, and then in the spring sky, you can see the Big Dipper. What else you can see? And the Little Dipper. And usually they use Polaris to find like where is the North Pole, where is the North, and then you can use it for traveling. It helps you. What else? Then, well, in the spring sky, you can see Libra and Leo the lion. And in summer sky, darkness comes a little day later because, as you know, when it's summer, the day is longer. You have more hours in the day and less hours in the night. So you have to wait a little bit to see the stars. And then you can see the Summer Triangle, which is and then you have the Lyra constellation, the harp. And you have Cygnus, the Swan, and Hercules, as you know, like as the movie. And it's a constellation, and it's like they tell the story of the hero of ancient mythology. Then in the autumn sky, You don't see much stars. It's like the less spectacular, but you can see Orion rising on the east. And then you have some types of stars that are always there. That's called a perennial sky. Perennial means that it's there always. So you have the polar stars that are there in every season and they don't set. They are called circumpolar stars because they seem to revolve around the North Star and they don't go below the horizon. That's the Little Dipper, the Big Dipper, Draco, Cassiope, Cepheus, and Camelopardalis. And also, if you want to see stars, which it would be kind of difficult in Lima without a telescope because you would need a clear sky, but if you ever want to do it, early evening darkness is the best time for doing it. Now I'm going to talk a little bit about the geocentric theory. Okay, the geocentric theory means that people believe that the Earth was the center of the universe. It started with Aristotle and was modified by Ptolemy. They thought that the Earth was the center of everything, as I already explained. Aristotle thought that the Earth was the center and then the heavenly bodies, meaning the stars, the planet, revolved around it. He saw that everything was fastened to crystalline spheres concentric to the Earth, so it would move like one ball inside the other. He saw first we had the atmosphere, then the four elements, then something that he called ether, and then outside all of that, there was something called the prime mover. The prime mover would be the concept of God, a force that keeps everything in motion. So at least he got that right, that there, like somebody created something was giving motion to everything. But the problem with Aristotle's concept was that the stars didn't move how he expected them to move, if everything was in a crystalline sphere moving at the same time. Some stars seem to move backwards. Then Ptolemy worked on Aristotle's idea, still, that the Earth was the center. But then he used the concept of epicycles, meaning he believed that each star or the planets moved in small circles, but then revolve around the Earth at the same time. Of course, that didn't make a lot of sense for observations, but that's what they believed at that time. Then we have about wanderers. That's how the Greek calls the five bright objects that didn't move the way stars did. We call them planets. They call them wanderers because they seemed like they were moving around. Mars, Jupiter, and Saturn always appear brightest when they're halfway along their backward paths. Okay, so the conclusion that the Earth was the center of the universe was based on appearance. It appeared that it was the center, but then if you paid a lot of attention to the stars, you would start to think that it didn't make a lot of sense. That's what Aristarchus started to think. He didn't believe that the Earth was the center because if it was like others thought, the planets and stars attached to these spheres that spin around the Earth would change. They wouldn't change brightness, because if they were like one day riding more and then one day less, that would mean that they were moving closer or far away. So that didn't make sense. He suggested that the sun was the center of the universe. Well, we know that not of the universe, but at least of the solar system. Yes, in that part he was right. And he said that the Earth was a planet just like the other planets moving around the sun. So he got that right, actually, but people didn't agree with him at that time. They believed that the Earth was the center of everything until the 15th century, a long, long time. Another thing that your lesson talks about is meteors. You know that, I don't know if you have ever seen it. I don't think that you've ever seen it in Lima, but I actually could see it like far up north in Peru. I once saw shooting stars, falling stars. That like seems like stars are falling from the sky. Actually, those are meteors. Okay, space is full of metal and rock that move at a high speed. When they move in space, they are called meteoroids. When they enter the Earth's atmosphere, they give heat and light off. And when once they enter into our atmosphere, it is called a meteor. But when it falls on the ground, when it's like it's here in the planet, we call it a meteorite. Most of them disappear before they even hit the earth. They just burn. And they can be as small as a grain of sand, or they can be huge, like great boulders. And most of the meteor dust is composed of metal, iron, and nickel. And since both of them are magnetic, actually, if you drag a small magnet through the ground, 10% of what you get of that dust is dust from outer space. That's crazy, right? So you can have a little bit of outer space with a magnet. Meteor showers are named according to the constellation from which they appear to fall. See, they appear to fall from Leo, then they're called Leonites. If they appear to fall from Orion, then they're called Orionites. And that would be it for today.